So this is the lesson for heats of reaction and Hess's law. But for now, we will focus on the heats of a reaction. You already know what a heat of reaction is. You did it in the lab. So do you remember the symbol for it? It's delta H. That's the heat or the enthalpy of a chemical reaction. Did you know that as a chemist, you're able to get the heat of reaction for any chemical reaction that you can think of? For you, how did you find the heat of reaction? Well, what we did was we went to the lab and we found the kilojoules using the calorimeter. We found how many moles we had, we divided by the moles, and we were able to get the delta H of the reaction, which is the same as the Q, correct? Another way to do that is have somebody else do it for us, and then they put it on a table, and all we have to do is use it, just like this table, okay? So first, let's go ahead and let you know how to get the heat of reaction using a table. If you look at the table, these are all heats of F, okay? The F is not the same as a chemical reaction. The F stands for formation. Okay, standard heats of formation is different from reaction. Formation. Formation means that you are making the substance the delta H, of course, is the enthalpy or the heat, the same thing, the energy. And this little circle right here means standard. Standard, what I mean by that is standard conditions. All of these data in this table, standard condition, are using the same temperature, 25 degrees Celsius, same pressure, 1 atmosphere, same molarity, 1 molar, same concentration, I mean. Okay? So, let me show you what delta H of formation means. It is the energy transferred, so it can be either endo or exo, transferred when you make the substance. Okay, so let's see, we want to make a mole of CO2. To make one, and by the way, these are all for 1 mole because they're molar for every 1 mole. Okay, so let's say I want to make 1 mole of CO2. I want to make 1 mole of this. To make this, I have to grab on Earth carbon. I also have to grab some oxygen. Now, when I take it from the Earth, carbon naturally occurs as charcoal or graphite, it's called. Okay, the reason I know that it naturally occurs as graphite is because when I look at the table, carbon, do you see this? It takes 0 energy to make it, so I know it's already like that, okay? And then I look at oxygen. When I grab oxygen from the Earth, I see that it's, let's see, O2. That's how, because it took nothing to make it. It's already like that. So I'm going to take O2, and it's a gas. So I'm going to take those, and I'm going to make the CO2. Okay, so I'm going to make, and to balance the equation, this is a 1 and this is a 1. I'm going to take 1 mole of this carbon, 1 mole of oxygen to make 1 mole of CO2. Okay, and then when I make that, I put it into a calorimeter and I see what the delta H is, which I'm going to get in kilojoules, and then I'm going to divide it by how many moles I make or I used. Okay, here's another example. Let's make 1 mole of O2 from its elements. So I want to make O2. When I look at the chart, O2 is already O2 and it took 0 energy. Okay, so it is already O2 gas on Earth. So it took 0 kilojoules to make it. Okay, let's go ahead and look at all these delta heat formations. So to make calcium, it's 0. What does that mean? It took no energy to make it. No energy is needed to make it because calcium is already like that. Calcium is already a solid on Earth. I didn't have to do anything to it, so 0 energy. If I wanted to make CaO solid, I have to combine calcium and oxygen, and then when I combine those, I'm going to give off this much energy. That's how much energy it took to form or to make that, and so on and so forth. So if I ask you, how much energy does Cl2 make to form? You're going to say 0. 0 kilojoules for every mole. If I say, I want to make HCl, how much energy is transferred? You're going to say it's going to need to mix H with a Cl, you're going to give out as exothermic 92.3 kilojoules if you had 1 mole of that. Those are all the heats of formation. Okay? So note, elements in their natural form has delta H of formation equal to 0. Okay, and remember, these are all in the standard conditions, the same temperature, 25 degrees, and that's what the little circle means. Okay, so let me ask you another question. How does silver naturally occur on Earth? You're going to say it occurs as silver solid because it took no energy to make it. How does sodium naturally occur? It occurs as sodium solid. Okay? So, writing formation equations. Just in case you want to know how they got these numbers right here, all they did is they combined the elements together to make it. For example, let's say letter A. It says, I want to make silver chloride. Okay? So, I want to make AgCl. AgCl solid. At standard conditions. So, I have to look at the chart here, and these are all in standard conditions. Standard conditions means same temperature, temp, same pressure, same everything, same conditions, same concentration. They're all standardized so you can compare them. Okay, so to make AgCl, it says write a balanced equation for the formation of 1 mole. So I have to make these 1 mole, okay? There's no exception because all these are tabulated in 1 mole of the following compounds from their elements. Okay, so I'm going to make AgCl from its elements. I'm going to pick Ag, and I'm going to mix it with some Cl to make this. But I have to make sure that these are from how it naturally occurs. So I go to Ag, and then Ag is 0 if it's a solid. So I'm going to put solid right here. Cl naturally occurs as a diatomic gas because it's 0 right there. So Cl naturally occurs at Cl2. Okay. Now, to balance this, it looks like this has to be 1 because the numbers, to form this one as AgCl solid, here's the energy I get. I give off this much energy if I make that 1 mole of it because this is only for every mole, kilojoules for every 1 mole. So this is going to be negative 127. It gives off negative 127 kilojoules. For every 1 mole of this, which means this is 1 Cl, this is Cl2, I'm going to have to put a 1/2 right here. Okay, just to make this 1. I know you can't have a half of an atom. It's just used to make this number equal to 1. And then this is the 1 right there. And you don't have to write that 1, but you can if you want to. Okay, why don't you do, I'm going to do 1 more. Let's do the second one, and then you can do the last one yourself. You want to make calcium carbonate. So I'm going to make calcium carbonate, and it's a solid. I wonder how much energy it took to make that, to form it, F for formation. So I look at the chart. CaCO3 is under calcium, I think, right here. It'll give off negative 1206.9 when that is what comes together. Negative 1206.9 kilojoules for every mole. So this has to be 1. Okay? Let me just make sure it's right. Negative 1206.9. Okay, so to make that, I need to mix calcium, I need to mix carbon, and I need to mix oxygen. Okay. Calcium naturally occurs as solid, is a 0. So I put solid here. Carbon naturally occurs as graphite, 0. So charcoal, graphite. And oxygen naturally occurs as oxygen, I'm assuming it's right here. O2 gas. That's how it naturally occurs on Earth. O2 gas. Okay, now to balance it, I have this is 1, so this is 1. This is 1, so this is 1. This is 3, this is 2. So I'm going to do 1.5 because 1.5 times 2 equals 3. So what does this mean? To make 1 mole of CaCO3 solid, to form it, I need to take this, this, and this, put it together, and I will give off this much heat if I had 1 mole of this. Okay, your turn. Letter C. You are going to make HCN. Okay, pause the video and do that. Okay, to make HCN, it is a gas. I'm going to need H plus C plus N. H occurs naturally as H2, I think. H2 gas, 0. H2 gas. Carbon is a graphite. I'm just going to do graph for short. And nitrogen is N2, 0. N2 gas. Okay? To balance this, because this has to be 1, I'm going to make this 1/2. I'm going to make this 1. I'm going to make this 1/2. When you combine those together to form HCN, I will give, or I will need 135 kilojoules for every mole of this guy. Okay, so the reason I did this is because I wanted you to understand these heats of formation. Is the energy needed to form all of this. Okay,